So theoretically, 232, just to make the board smaller, it should just work. Yep. And if we did 128 to make it twice as big, that'll also just work. This is better. Let's just do that. Welcome back to Arcade. I am Super Tommy, and this is part 2 of our series in making Tic-Tac-Toe with Colyseus to show you how you can work with multiplayer socket servers to make a multiplayer game. So when we left off, we took our basic project setup and then just set up our game scenes and our server service to communicate with the server and then let us know what we should do on the phaser side, the front end, or the client. So do check out part 1 if you missed that. So we're going to be building on top of what we did in the last video. Now, we left off by creating this basic state using Colyseus schema, and we just made one property here called name, gave it the value T-T-state, just to show you setting down that state and setting that per room. So now we're going to change the state so that it's more specific to Tic-Tac-Toe. So let me shrink this. Send me over here. So we're not going to need name. I don't think that's relevant. We can always add it if we need it later. We will want to know the board, right? Now the board is, in Tic-Tac-Toe, a board is 3 by 3, so there's 9 cells. And we're going to represent that in an array. Now in Colyseus, in the schema, what do you call this? Schema setup, or the schema type, let's say. For it to serialize arrays properly, you have to use the array schema. So array schema. So schema is like for any object, and then array schema is specifically for arrays. There's also other things like maps and I think sets. So in this case, we're just going to use the array schema. So here, the type is array schema, an array of number. I thought I was writing in C for a second. That was strange. Okay, so type we're going to do is this array syntax, this list syntax, and it's going to be number. Number. And let's do a constructor here. We could set it inline here. I just basically do this. I guess we could, why not? I was going to do it in the constructor, but we could just do this, right? And the alternative, what I was about to do is just set it in the constructor, but you must call super when you do that, and then we can do this .board. Gets new array schema. We'll just do it this way, because we're going to want to put items in here, which is going to take an array of numbers. So we're going to set that all to 0. Let's see, it's complaining. Oh. No. I just want to do this. But this means it's taking an infinite number of items, a variadic parameter. So basically any number of items, and it's going to be treated as an array of numbers. So that's what this is going to ends up being. Okay. So that's our array schema. That's our board. Next, we want to know whose turn it is. So let's say, let's call this active player. So set it to 0, and it's going to be of type just number. So you see, it's not list number or array number, it's just number. That difference between those two. And we set that as 0 inline, like we were saying earlier, we can do for this. So both ways work. Okay, so now we have that. Great. Let's do that. Now let's refresh this guy. Now room, in part 1, we looked at the state property and we saw there was that name property with the triple T. Now it should be updated. Right now we've got the board. Now this array is going to look different. Well, it looks great. Oh, this is good. Okay, so sometimes I've seen it come out a little bit differently, but nonetheless we have an array of 9 values, 0 to 8, all zeros. That's excellent. Now player index, also 0. Okay, so we're looking good here. Now this gets sent down with us when we create the room. So let's come here. We want to go to our server service here. So the server.ts file. And on the room, do room dot, too many spaces, room dot on state change. This is when the state changes. And now let's just do once. So this is the initial state change. So what does this take in? A callback with unknown state. So let's just say, let's do this. And then console.log state. Refresh, and here's the state, which is basically the same as the state in the room that we looked at because it is here. So this dot room dot, room dot state. So let's say we do console.log and then do that. I think, let's see if I'm right. Nope. So they looks like it came down at the same time. Let me just double check that. False. Okay. Yeah. In this case, so when the room is created, it sends down the state with it immediately, which is fantastic. So we may not even need this once. But in the event that that doesn't happen for whatever reason, it looks like it is happening. We can always do onStateChange.once, and then to know that we've gotten that state, we can do something with it. Okay. So what we will do here is tell the game that we have a state and that we should draw it out. So in this case, it's our tic-tac-toe board. It's just going to be a 3x3 grid. So what we're going to do is use event emitter to emit events when things happen from the server that our client needs to respond to. Let's go here. Let's call this events. Now, of course, Phaser uses this all over their API. So it's all over Phaser 3. And we're going to do it the same exact way. In fact, we're just going to take Phaser's event emitter. So just import Phaser here from Phaser. Now, this is the front end, so we could import Phaser. We can't import Phaser if we're in the server backend side, the Node.js side, since Phaser is not designed to run on Node.js. So Phaser.events.event emitter. And let's just say we do this.events, new Phaser.events.event emitter. So no longer need to log that. And then we can do this.events dot emit. And let's say we emit on state changed. Or about one state changed. And it's going to be state. Now, in order to handle that and to make this better typed, right, we can do here once state change. Right, we're going to make a method here called once state change. It's going to take a callback, right, just like this, and that callback is going to have a state. Let's just for now call it any, and it'll have a context in case you need it, which is also any. And what this is going to do is it's going to do this.events.once, right? We're basically listening for, so this is event string, which is going to be this, once state changed. Give it a callback, which is this callback we're taking, and any optional context. Cool. So once we go, so we have that, great. We can go to game here, and what we can do, let's make this async, so that we only start doing this after the join happens. So we're going to do await join. I'm going to do server once state changed. Basically, we're passing this forward so that the game can handle it. And so we'll just log the state again here. Instead of handling the logic here, all we're handling here is that something that the server sent us a message we want to let everyone know. So yeah, I already fixed that. Just make sure it recompiled that. and then we're going to send it forward and let the game handle it. And so this should be the same, right? Yep, that is all good. And so from here, we can actually create the board. So let's make a private method here, create board. Let's say it takes a state. Now, this any state is not ideal. We want to actually have some better type information. So let's do that. Let's go out here, and in the source folder, so at the root of source, so not in client, not in server, we're going to do is have shared types. Let's make a types folder, and then let's just call this tick. What should I call this? This is like tic-tac-toe state. So I tic-tac-toe state. And so we're going to export an interface called I tic-tac-toe state. And so it's going to have, as we know, board, which is an array of numbers, and then an active player, which is just a number. It's going to be the index of the connected player. Good. Just do export default here as well. Okay. And then in the server here in tic-tac-toe state, we can have this implement the interface that we just created. So import I tic-tac-toe state from one types tic-tac-toe state implements I tic-tac-toe state. Now we're doing this so that the code on the server and the client are not actually together. Like your phaser game is going to be bundled and it's going to be served from a CDN or a HTTP request, but our server code is going to be taken and then copied to a web server connected to via WebSocket. So they're in two different places, and so they're not actually, they don't share code at runtime, but they can still share typing code so that you have the right types when you're developing to have less errors. Like we can't import this schema into our front end since this is only for our backend, but we're going to share it with just our typing file, right? So that's why we're doing it this way. Okay, so in our server here, no, wrong one. In our client, in our server service here. So this state, because our room is unknown type, so we can do this in this generic here. We can just say I tic-tac-toe state room. So now that's the room of this type of the room, and then so this will be this, and now. So right now, it used to be unknown, now it's something. Then I tic-tac-toe state. So now this is more strongly typed. So when we come to game here, this state is I tic-tac-toe state, I tic-tac-toe state. Great, so then we can do things like state.board, right? We have all that information because we gave it a type. So that's awesome. Now, what we can do here as well, so that we can access this inside this method here, we can change this to a class property arrow function. I did that right. No, sorry. It should be this, so that we can do this dot create board. Right, so this is one option. You may not want to do this. So on one state change, we have this context. If we don't pass in the context, then this will be something else. Maybe it's be window, or it'll be just not the class instance. So we can use this syntax if we don't want to do like this port dot this. Right. Like you've seen that in a lot of the other videos. There's just one potential shortcut if you're looking for it. You don't want to be, passing in the method and then the context, or just to have less typing or make it easier to read. this is one option. So this, what we see here, is equivalent to this, where we turn this back into a regular class method. So those two are basically the same. There are some caveats, but they're basically the same. So let's just go with the more traditional method or way for now. So one state changed, we're going to call the createBoard method here, give it the context, which is this class instance. So here we want to draw out the board given our state. So state.board, just go for each here. For each. Now there's going to be a value, which is a number. Let's just call this cell state for now. So 0, we're going to say is empty. And then 1 or 2 will be X or 0. And now for each cell state, we're going to want to do this dot add dot rectangle. Now we need an X and a Y. So let's just say we're going to start let's just start it easy. Let's start it at XY 100, right? Let's just arbitrarily say we're going to start drawing the board from here. And then we'll say each cell is 64 pixels wide, let's say. So X, Y, width 64, height 64, fill color, let's make it white. Good. And then, so we have one array, but there's a board. So for every three cells, we want to go down a row. So in this for each, there's also an index. In this for each, there's also an index, which is the second parameter here, idx. So x plus equals, let's say 64, and then let's add a little gap in between. 64 plus 5. Now if idx, then this is mod 3 equals 0. We have to check that. What I'm going to do is y plus equals 64, just say the gap is 5, and then x gets set back to 100. Let's see if this works. Okay, not quite correct. Let's see. So it does 1. So let's check this. I always forget exactly what the specifics of the mod should be. So what mod does is it gives you the remainder. So actually, I also have to do this. You just go to, so let's say 0 mod 3. The value. I think I just type this into Google. 0 mod 3 is 0. Let's only get this reversed. 3 mod 0. Mod 1. Mod 1. 1 mod 3 is 1. And then 2 mod 3 is 2. 3 mod 2 is 1. 3. So 3 mod 3 is 0. Right, so when it's 3 mod 3, so if it is 0, so 0 is that, so we don't want to do it on 0. 1. Okay, it's definitely this way. I just trial and error here. So remember what the mods are. 1. Oh, no, actually, I don't think I need mod here. Right? I'm being silly. Okay, idx, so 0, 0, 1, 2. So that's the first row. 0 divided by 3. 0. 1 divided by 3. Right? Okay, yeah, I'm being silly. I think this is right. Okay, IDX divided by 3. That's actually going to be... Am I being silly? I forget this math sometimes. 1 divided by 3. 2 divided by 3. 3 divided by 3 is 1, which is the next column. So let's say 4 is 1, so that is the next row. I'm pretty sure I use mod. Your brain is harder to think when you're recording yourself. 1 mod 3 is 1. 2 mod 3. Then 3 mod 3, and then 6 mod 3 is also 0, right? Yeah, so every time it is, I want to move except for 0. I feel like this is what I normally do, but just go with it, see what this does. Okay, so 0, let's just go through the breakpoints. Game.ts. Come down here, refresh. Okay, so IDX is 0, so we're going to put it at there. So this is the next x, right? IDX is not greater than 0, so then we pull in at 64 plus 5. Okay. So now IDX is 1, 1 mod 3. Where's my console? Right? It's not equal to 0, so it doesn't do that. So now I have 2, this is 3, 4. X goes down 1. Y. Oh. Right. Here we go. Okay. So there's a modulus just for getting the first 3, the second 3, and the third 3. Basically each segment of 3s. So we're doing mod 3. Each time it's 0, so basically 3, 6, 9, 12. Those will be separated into specific rows. So there's that. I'm going to do some math. I'm generally a fan of trial and error. I don't remember some of this all the time. And then when you do divide by the total length of the row that you want, that's when you can calculate which row or column you're at for a different tile math when you have an array that represents your tiles. So I get them confused sometimes. Okay, so we have our grid here, but we don't need to start at 100, 100. Let's just put this in the middle here. Just move this. Okay, so let's say instead of that, let's put this in the middle. We want the width and the height of the game, which is going to be this dot scale. The scale manager has width and height. And let's just say width times half. So it's not going to be not quite it yet, but let's see. It's going to be like offset over here. Oh, right. Going to be offset over here. So now we wanted to bring it back over, basically, since this is the middle, right? So basically half is going to be like right around here somewhere. So we want to move it back over. In this case, I think it's minus 13 because our cells are 64 by 64. No, not 32. Minus 64, which is our actual 1 unit, one grid size. And there we go. So that's in the middle. So for better here, I'll just call it size. Call it 64. Do that, and that, that, that. So replace all our 64s with a size variable, so we just change that. Great. So theoretically, we do 32 just to make the board smaller, it should just work. Yep. And if we did 128, make it twice as big, that'll also just work. This is better. Let's just do that. Okay, so let's do 128 there, and this is our cell state. We will use this to draw the specific thing on it. So it could be an X, it could be an O, or it could be blank like this. So we'll leave this for now, but we can reuse this to basically, not reuse, but if you entered the game in the middle, for example, and the board state has changed, you're gonna want to know what this cell state is to draw the right thing. So now if we connect our other guy just to see, yep, they're looking at the same thing. Okay, so that is this part 2. We added, just to summarize, we added a board property to our schema state, and we added active player. We haven't handled that yet. We're going to handle that in the next part. Now then we take our board state and draw it to the screen. So we start, of course, here with just 9 empty squares. And when we click on each one of these squares, we'll let the server know that the player made this choice. And then whether you're an X or an O, depending on when you joined, we'll update this with the X or O. So we have the basis for that in this part 2. Now, if you like what you saw, be sure to hit like on this video and subscribe for more videos on creating games with Phaser 3.50 and Colyseus.